Yeah, we'll start the class. Okay. So let me go to the SQL file. Okay. Let me explain about this editor. Okay. So actually, most of the traditional databases, what we do, we used to go to, we install the environment and then we install the tool like pgadmin or dbviewer like that, and we connect the database to the dbviewer. But when it comes to Snowflake, right? So Snowflake comes with inbuilt web tool. Okay, this we call it as uh, console. Okay, so in console now we have a latest option called workspace. This is recently added. In November they added this option called workspace. Okay, so what is this workspace? Similar to this DBT project or the Python project. Okay, let me create new workspace. All private. Okay, here we have option. Rename this private workspace. Let me create my own private workspace. I want to create a pipeline. Okay, pipeline CRM. Then create. So your workspace has been created. Assume this pipeline in this project you are going to build AML models. For that one you require logo, HTML code, all those things. Okay, so everything you can upload into this folder. So my workspace has been created. If I want, I can create a folder, assets, then folder CSS, then folder JS. Like that, I can create my own folders, and then I can upload related images, all those things into this one. Let me upload some image. I'll upload this one. You can see that I have uploaded this image and I can use this image in the Python script to build the AML models. Okay. So this we call it as a workspace. I can create a private or public workspace and I can provide the access to the other users so that other users can access this workspace. This will help us to write the PySpark. Here we call it as a Snowpark. This will help us to write the Snowpark script and what we call those built a Streamlit and Cortex A applications inside the Snowflake portal. Okay, so here I can add what call notebook, nothing but PySnowpark script, and then I can add SQL files or Python files inside this workspace. Any doubts to about this workspace?
So are we uploading the databases?
No, no, no. Not the databases. These are for the writing the script. This is to paste the file. See, for example, if you will write the Python scripts, right? It's not related to SQL. It's completely related to Python, PySpark, and all those things.
Okay.
Yeah, to write the DBT scripts, all those scripts. If I want to write and store, this is the place where I can write and store these things. Okay. So then now let me add a file, SQL file here, and then I'll rename it as a DDL. All the objects, whatever I created, that way I'll store it here. Okay. And this is a worksheet. So if it is an individual, right, those will be placed here. My laptop size is not supporting. Done. Now let me go to this worksheet, and then this is a database explorer where I can see all my. It's like a catalog only. I can see my database schemas table, all those things from here. Okay. And if I don't want this bar, I can hide this one. If I don't want this bar, I can hide like this. Okay. So this is my console. Okay. So here in the console, I have first, I need to understand four major things. One is this role. So there are total seven. 1, 2, 3, 4, 5, 6, 7. There are seven system defined roles. And then this is the warehouse. provided by Snowflake. So if I want, I need to create a custom warehouses in the menu in the warehouse option. Okay, so this is the role and this is my warehouse, and here I have a other option, database, and then the schema. Okay, so now I want to create my custom schemas. Okay, our custom database. So how we create the database in the traditional database? Similar way we will create the database. Create database, database name. Okay, let me create a database called batch 53. Here I can add a comment. Okay, this is the option provided by Snowflake. This option you cannot find it any other database. The comment you can write why we are creating the database and what are the things we are going to store in this database. So it's like an informative purpose. So I'm creating ignore spellings. I'm creating the database for practice. Okay, let me create the database. The database has been created. So inside this database, what I'll create schema. Let me create a schema called S or DWH data warehouse underscore business comment. This comment is optional, no need of mentioning it, but if you mention, it will be more informative. All the business related information available in the schema. Okay, and then so like that, I'll create the objects by using these comments. Okay, now let me reload here. So whatever the database I have created or whatever the schema I have created, that will be available here. You can see here. Okay, so this is batch 53 and this is the schema I have created. Sometimes the session will not support. Okay, even though you have selected this B53 and DWH business, it will not work. So you need, because of the session, at that time you need to use a command called use database B53. Okay, so to switch the database from one database to another database, I use this command called use database. Similarly, if I want to switch the schema from public to other, so I need to use schema is DWH business. I can switch from one database to another database through UI, or I can use SQL commands for switching the database. Now, here there is a beautiful option provided by Snowflake, that is Snowflake AI. So this is the AI we have. Click on AI. Okay, create customer table. Okay, with columns ID, comma, name, comma, phone, comma, email. So this is the AI will help us to do whatever the instruction we have given. It will do it. If this is correct, you can click on keep. If not, you can click on undo. This is correct. I'm clicking keep. Now, if I so I can create this table. Okay. Now let me use one more instruction. Placeholder here, AI here. So need to see the data of customer. So you don't need much prior knowledge because now AI is doing everything. Whatever the instructions you will give, it will write the query and it will share with you directly from the console itself. Clear? Any doubts? Okay. Then this we call it as a run button. So to execute the query, and here I have option for run all to execute all the commands. And then let me put placeholder here. Here I have a three dots where I can click on format query. The query will get formatted in a proper syntax. Okay. And then I have a search in file. I can search whatever I want. Let me search for B52 sorry, B53, right? B53, wherever there is B53, I can search in the file. Okay. And then this is option for sharing and move files to shared workspace, copy code. So this is option for sharing the document. Next, yeah, these things we'll discuss in the later class. Okay. Now coming back. Okay. Now you see here. Okay. This we call as a result set. Okay. In the result set, there is an option called this time. Okay, this we call it as query history. Click on here. You can see whenever whatever the query you executed, that query will be executed with a query ID. Okay, to know what exactly happened in that query, that way everything will be stored in this query ID. If you click on this query ID, you can see the complete information, what he has executed, how much time it has taken. Okay, what is the result he got? What is the result he has seen? So, and then in the query profiling, how much time it take to create that to what we call the query plan, and all those things you can see in this query history. So every query will have some ID. With the help of that ID, you can get all the complete information about that particular query. Okay. Now, then I have option here to download. Okay, I can download in CSV, XML like that. Okay. And then there is an option for chart. I can create the charts based on the data. Let me insert few records. Insert dummy records into the table, into the customer table. All right. Now what happened here? So if you see the query history, let me re-execute it again. So it has taken 83 milliseconds. Why? So it doesn't go to the storage layer. It doesn't go to the storage layer. Okay, where it is getting the data from the what we call metadata. Okay, in the metadata we have all the column names, right? This data is I'm getting it from the metadata. It's not going to the storage layer. But when I have insert this data, right? Let me insert these records. Keep and then insert these records. Now these values are inserted into the what we call the storage layer. Now when I execute this query, now you see here, okay, let me go to here. So compilation, which means the plan, and then this is for execution. Let me go to the query history, and then you can see here the complete profile query plan. Okay, first it has scanned the table and then it has printed the result. So here you can see how many partition it has scanned. So all the values are stored in single partition. That is the reason it has scanned single file. Okay, and then so yeah, all the files has been scanned, nothing but the single file has been scanned, and then the results are printed into the a result area. Now if I execute the same query, right, if I execute the same query, now you see it has taken only 89 milliseconds, which means where the results are, where the results we are, from where we are getting the results from the cache layer. So this is a cache layer. Directly it is printing the results out from the cache layer. So it doesn't create any plans or nothing. It directly jump into the what we call cache layer and extracting the data. So as highlighted before in the last class, so this cache results will be stored up to 24 hours. Any doubts about this query processing? Now I can download as CSV, Excel or TSV. So these are the output options I have. And then I can create a charts based on this thing. So not name, an ID. It's not a bar chart, line charts. Okay. So I can create a chart for the better understanding. This we'll discuss in the later class. So any doubts up to here? Team? Any doubts about this UI
No
thing?
doubts.
Okay, done. Let me go with the slide. This one, going back, registration, table types. Okay. Let me discuss more detail about this storage layer. Okay. Now let me start. So yesterday we have discussed about the architecture level. Today we are going to discuss in detail about again about the storage layer. As highlighted before, so Snowflake will support unstructured or semi-structured data to load into the database. What is the storage capacity of this Snowflake is infinity. Okay. So coming back, so we already discussed how the data will be processed in the database. Whatever the data I'm inserting, it will be stored in the form of a micro partition. Okay. So now you need to understand these object names. Okay. The first object you need to understand is a organization. Manage one or more Snowflake accounts. Set up and administrate Snowflake features which make us use multiple accounts. Monitoring using across accounts. So first class object that link multiple Snowflake account under one business entity. Enable centralized management across region and cloud platform. Unified view, simplified billing, seamless data, easier replication and failover setup. Okay. So this organization account you cannot access with the free trial. And this is not much important, but you need to remember, okay, whenever I'm creating the mails, right, Snowflake, let me refresh again. So I think I didn't receive it. No, still I didn't receive that Snowflake. Fine, I'll wait. So some issue here. Fine. So whenever I registered with the same email ID, same email ID, right? So whatever the accounts I'm creating, right, it will be created under one single organization. So what is my organization currently? The mail ID I have provided here. So under this mail ID is nothing but organization. Under this organization, I can create multiple accounts with the different locations and the different cloud providers. Okay. So mainly we use this, we cannot access the organization account with this free trial. But what is the major benefit of this organization account? So we can monitor the billing and all those things, and I can create multiple accounts with SQL query also. This I cannot do as it's a free trial, but it's not much important. Okay. So when we go with this organization account, so most of the projects I worked, right, it's related to single account only. Okay. So when customers will use organization account, so whenever they have multiple businesses, right, whenever they want to create multiple each account for the each project like that, then they go with this organization thing. Okay. So with this under organization, you can create multiple accounts. Okay. So, and again, these objects, Snowflake objects are classified into two types. One is account level object, another one is database level objects. So, under the organization, we'll create the account, and then account have the some Snowflake objects. What are the objects we have? We have database, warehouse, then this side we have users, roles. These four you can easily understand. Okay. After that, we have an option called network policy. Then we have an option called share. This is like sharing our application with other Snowflake user. This we'll discuss later. And then this is a resource boundary where we can create a rules. So whenever that warehouse is charging more credits than our plan, then we can stop the warehouses in the middle of the operation by creating a resource boundary. So these are the objects that Snowflake is providing. These objects we call it as a account level objects. Second, we have database level objects. So how we classify the database objects? So to categorize the database object, we use schema. Schema is like a blueprint. See, if I want to categorize the objects, okay. So for that one, I create all the objects under the schema. If I'm not using any schema, right, all the objects will be created under public schema. Okay. So what are the database objects we have? So we have tables, views, materialized views, procedures, functions. Along with that, in the Snowflake, we have a database objects called task, stream, pipe, and then these stages. Okay. We will discuss this object in the later class. So, so that's it. So you can classify the Snowflake objects into two types. One is account level objects. The second one is database level object. So any doubts up to here? No, right? Okay. Let me zoom into the database level object. Okay. So what is database? So what is the use of database? Okay. In simple terms, assume database is like a supermarket. Okay. So how the supermarket will be arranged? Okay. So everything is properly organized and stored. Okay. So assume if you went to any supermarket, okay, all the groceries will be in one rack, all the electronics will be in one rack, all the clothing will be in one rack. If it is a multiple stores, right, we have a blueprint. Okay, first floor this, second floor this, third floor this, like that. We have multiple racks, right? And all the objects, all the what we call the products will be placed properly. In the similar way, in the database, we have multiple objects, nothing but multiple racks. Okay. Each object will hold some information. If you take the table, right? If you take the table, table will hold the data. If you take the view, view will hold the query. If you take materialized view will hold data plus query. If you take these procedures and functions, it will hold the script. Like that, each object will store some information. Okay, all the these objects are organized and stored. Okay, second, see, assume you have went to a supermarket. There is no blueprint of it. Okay, where the in which floor the products are available. Now, if I want to purchase an iPhone, what I need to do? I need to check each rack. But if I have provided some blueprint, right? This electronics will be available on the second floor. For what I'll do, I'll enter into the uh, supermarket. I'll see the blueprint and I'll directly go to that particular object. In the similar way, if I create objects under schema, schema is like a blueprint. Okay, it will categorize the objects. Okay, if I create an object under schema, right? So data for retrieving the records or to processing anything, right? It will become easy for the database as well as for us also. Okay, so there are a tables. Okay, employee, what we call employee payroll, like that. So all these tables I will create under HR schema. Okay, there is a tables called product, sales, transactions, customer address, all those things I will create under a data warehouse or business schema. Like that, I will categorize the objects with the help of the schema. Schema is like a blueprint. It's not an object. It's like a blueprint where it help us to organize the database objects. Okay. So any doubts about this database and then the schema? Any doubts about this database and then about this schema?
So, are we organizing the tables or the databases? Do we have multiple databases in one script, or
Yeah, in
is
Snowflake, you can use multiple databases in one script, only in Snowflake. You cannot use in another database. Here, whenever I want to use another database value, right? So I'll call here. See, here I'm in batch 53, right? I can call select abc.dwh dot customer. Let me, I forgot the table name. Let me go products. Let me go here, catalog. Takes some 1 minute. Stuck. I can call directly. Okay. I can call
okay?
directly with the table name dot schema name dot product name. That is the query. Only in the Snowflake it's possible. You cannot do same thing in the other databases. For the other databases, you need to create DB links and there are other options. By creating those links only, we can access from another database table in the current database.
Okay. Thank you.
Sir,
Yep.
sir, like you were explaining about objects, right? So I
Yeah.
want to know that when we are referring to database objects, what do they reflect on? Like, what does an object actually hold? Like, is it a I mean,
Sorry, I didn't get your question. What exactly?
what exactly does an object reflect? Like, what does it represent in real life analogy? If you say,
Okay. Simple terms. Okay. If I want to store the data, where I can store the data?
okay, so that is an object.
Yeah. So if I want to store data, there is only one object. It support that is nothing but a table. Okay. If I
Okay.
want to create a pipeline nothing but the script which help us to transform data from one place to another place, nothing but from one table to another or from one database to another. So to create this pipeline, nothing but to execute to execute this script. First, I need to store the script, right? Where this script will be stored, the script will be stored in this procedure. Okay. So I want to create a schedulers. Okay. At 11 o'clock, this script will need to be executed. At 12 o'clock, this script will need to be executed. Where I can store the scheduler, the information that will be stored in this task. Okay.
So these objects are more like jobs, right?
No, 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 not jobs. Assume it's like a containers. So each container will have some information. Jobs, again, it's a different story. Assume these are containers. This task is a job. Okay. It will process the data at particular time. Whatever the time you define in the task, the data will be processed. Okay.
Okay.
So it's assume it's a container. Each container will have some information. Table will have data. This procedure function will have script. This task will have the parameters for executing the job. Okay. Like that view will store the query. Materialized view will store the data plus query. Getting it right? This stage will have the files to load into the table. Like that.
Yeah, got it. So like we can say as of now for now that an object is a container with some sort of information.
Yes, that's
Right.
it.
Okay, that's it. Thank you.
Okay. And to organize these objects, right? We use schema. Schema is like a blueprint. So where exactly we have placed the objects. Okay. So you need to remember in under an account, you cannot create a database with a same name. Okay. Under a single database, you cannot create a schema with a same name. Under this schema, you cannot create a table name with a same name. Getting it right? So all the object names should be unique under this particular database or schema. Okay. Done. Any doubts? Next, we'll discuss about data. So what exactly mean by data? Okay. Anything that is written on paper that we are storing, right? Any piece of information. It may be on paper, it may be on Excel, it may be a notebook, it may be in database that we call it as a data. So data refers to raw or measured facts, figures, observation that can be processed or analyzed to generate meaningful information. It's the foundation of information system, play a critical role in decision making process across various fields. Done. So now this data is classified into three types: structured, unstructured, semi-structured data. Okay. Based on the okay. So where I can store this data, I can store on this, and this. Okay. Notepad or Excel, anything, or database, anything. Okay. So for storing the data, why we are not using Excel? Why we are using database? Any answer? So why can we use Excel rather than database?
I don't think we can retrieve or manipulate the data in Excel, so we use
Yes.
database.
Yes, we cannot do multiple option, but the major reason will be Excel is not designed for storing huge amount of data. You cannot store trillions of records into the Excel. If you store in the Excel and if you try to open the Excel, it will your system or your server will get hung. So that is the first reason. Second, you cannot create relations between the data. For example, there is a column called name, okay, and then this. In the name column, if I enter some number, or in the date column, if I enter some string, so is the Excel is going to throw any error? No, right? It is not going to throw the any error because I cannot create any constraints or any relation in this particular sheet. So these are the reasons, okay, why we will not use database. What are the reasons why we not use database? Let me go here. So these are the reasons. First thing, security. So you cannot create a policies. Okay, this user can access only this limited data. This user can see these limited columns like that. We cannot create any rules in the security rules in the Excel. But when it comes to Snowflake, when it comes to SQL, I can write the rules. Second, this is designed for handling the huge amount of data. Third one, I can create relations between the tables. Okay, due to creating these relations and constraints, I can maintain proper data integrity. And the last one is it supports SQL, where I can write the complex logics on top of the details. Okay, so these are the reasons why I choose why I use database rather than Excel. Okay. Now, as highlighted before, we have three type of data. One is structured, semi-structured, and unstructured data. Okay. Structured data. What is structured data? The data which is in a readable format. Okay, that we call it as a structured data. So what are the data I'm storing in the table, right? That we call it as a structured data. Next, semi-structured data. To store multiple information with multiple values. Okay, I go with the semi-structured data. So in semi-structured data, there are majorly two formats are there. One is XML, second one is JSON. So here you can see, so all the data is stored in the form of key value pair. I can store multiple information as a single value. That is semi-structured data. The last one is unstructured data. So unstructured data means the data which is not readable. So that nothing but images, documents, videos, all those things. Okay, let me go here to the downloads. So let me open with Notepad. See, whenever I'm trying to read this file, right, it is not in a readable format. That is the reason we call it as a unstructured data. Okay, structured, semi-structured, and unstructured data. Clear? Okay. Now, in the current market, based on the type of data, they are choosing the database. If I want to store structured and semi-structured data, okay, each cloud provider has provided different databases. For the others, there is an option called Snowflake. Okay. For handling structured and semi-structured data, I use Snowflake. For unstructured data, I need to use either S3, AWS S3, or Azure Blob Storage, or GCS Cloud Storage, Google Cloud Storage. And if I want to go with on-premises, I need to install Hadoop HDFS, Hadoop system. Okay. So based on the type of my data, I'm going to choose my database. Clear? So this is related to GCP. Okay. Go here.
Sir, but Snowflake supports all three form of data, right?
No. It support all three, but we have a option called stages, but it it doesn't have much environment, I can say. See, if you take GCS or S3 bucket, right? It do lot of things. It maintain the versions. It will track a history. So there are a number of things will be there in the S3. But in Snowflake, we have an option called stages. It's like a basic only. It doesn't have much like S3. Okay. So we cannot write the policies and all those things, and we cannot share outside. Whatever the objects are there in stages, I cannot share directly with the outside. Okay, in the S3 can access it through the URL, right? I can add the domain and all those things. I can do n number of things in S3. Those things I cannot do it here. So that is the point.
Like like when we say Snowflake, even underlying every time underlying database layer is coming from the cloud itself, right? Like if Amazon, if AWS, it will get stored on S3. If Azure, it will get stored on blobs and so on, right? So
Yes.
and if we create an account with AWS, then we can only deal with that type of data that is allowed with AWS. If we create it with Azure, we can deal only with that type of data that is allowed with Azure. Like in the table previously, it was written like this supports this database supports structured, this supports semi-structured. Is it that so?
I'll tell you with this example. Okay. So how we get the data in the real time, how we get the data, how we'll get the data, either from a OLTP, a transaction database. From one database, I'll get the data. Okay. I'll get data through files. Okay. This is a CSV and then this is a JSON. So this is a structured data. So in the CSV, we have a structured data, right? And then if you take unstructured data, so JSON. Okay. And then we have APIs and all those things, blah, blah, blah. Fine. Now, where these files will be located in the real time? In the real time, client may place this file in the either in the cloud environment, nothing but AWS or Azure or anything, and then we have another called on-premises, nothing but normal on-premises or VPS server, normal server, not a cloud environment. Okay, so where the client is going to place the files either in the cloud or on-premises, where he is going to place the files in the cloud, nothing but in the S3 bucket, right? In S3 or blob or GCS, they are going to place these files in this here. Okay, the file will be available here. The file may be a structured or unstructured data. It will be placed here that we are going to process it with the help of ETL tool into the Snowflake. This is how it works. So this is your question or your question is completely different?
No, sorry. Actually, like there was a table right previously.
Okay,
If we
assume
had
this is your table. Okay,
yeah, about three types of data, and it depends on different cloud providers.
okay,
Uh, so like what does it exactly mean? Like you told us in the beginning that mostly while learning we create an account with AWS. Okay, so the underlying
yeah,
data layer that is using S3. Okay,
okay,
so while if we create our account and we can manage all three types of data with it, right?
okay,
Structured, semi-structured, and JSON. But
yeah.
does AWS support all of the three? If according to the table that was shown like
Yeah,
this.
but it support, but Snowflake will not utilize that one. This one you need to remember. Snowflake will not going to take any help related to this unstructured data. Okay, bro, like you are getting confused. I'll tell you. Okay, let me go with the paint. Okay, see, this is Snowflake account. Okay, whatever the data I'm storing and processing, it is using some assume I have taken AWS, right? It is using Snowflake AWS account. Okay. This is Snowflake AWS account, which I cannot access it. Okay. This is using by Snowflake. Okay. This is you need to remember. This is account attached to the Snowflake. This account I cannot access it. In the real time scenario, how I'll get the data into the table? How I get the data into the table? Okay, through files or a database or API or some IoT devices. So there are multiple options are there. Okay, if for example, if you take any file, okay, so that file need to be placed somewhere, right? Okay, so where they place these files? They place these files in the AWS or Azure or GCP account. Okay, so the files are placed here. Okay, for example, customer has placed the CSV file. So using this ETL tool, I will load all the data from AWS to my Snowflake account. Nothing but whatever the data I am inserting here, that will be stored in the storage layer. This we cannot access it. And Snowflake is utilizing only few services. What are the services it is utilizing? So to storing, it is using S3. For processing, it is using EC2 service. So these are the two services that Snowflake is using from the cloud provider. But in the real-time scenario, How we will get the data from multiple source systems? It may be on premises, it may be AWS, or it may be GCP, other services are there. So by using ETL tool, we are going to load the data from here to here. And Snowflake is designed to handle structured and semi-structured data. It cannot process unstructured data. This you need to remember. Clear. So I think your doubt got clarified. So this account is completely different from this account. This is a Snowflake AWS account, and this is our cloud, our multiple source systems where we get the data.
Yes, yes. My doubt mostly got cleared. Can you just open that table for a second, please? Like a table
Okay.
just moments ago, where
Okay.
not this table, the table, where it was mentioned like for this type of data, it depends on this type of cloud in the presentation.
Presentation. This one. This one.
Yes, 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 yes.
Okay.
Yeah. Um, so for structured, like
No, no, no. See, I'll tell you. Okay. So if you take this data, these all are same. Okay. These are all data warehouses for processing the data. Remember one thing. So if you take AWS, AWS is already having Redshift for data warehouse. If you take Azure, Azure having Synapse. If you take GCP, GCP is having BigQuery. But when compared to Snowflake, all these are shit. Why I'll tell you? Because Snowflake is supporting multi-cloud. Okay. Now you are a client, you want to store your business information in the Redshift. Okay. Now what is the problem here? Whenever whatever the pricing that AWS is charging, right? That you need to pay. If you want to migrate from AWS to BigQuery, right? Redshift to BigQuery, I need to pay lakhs of rupees for every time migrating from one environment to another environment. But in the Snowflake, I can do within a seconds. Okay, that is the first thing. It is a chargeable when compared to that, it's very less. That is the first thing. Second thing is like, so this Snowflake is having a time travel, what we call fail safe, that is not available in any of these database. Even though it has the time travel, but when compared to Snowflake, these are shit. It doesn't do that much effectively when compared to Snowflake. Even though these cloud providers have their own data warehouses, Snowflake and Databricks are far better than these two other cloud providers. So that is the reason, even though in the market we have these databases, cloud databases, everyone will choose either Snowflake or Databricks because these are far better than compared to these things. These are still in 100 meters long away from these providers.
yeah, got it.
Yeah.
Got it.
So these are like competitors only. These are four competitors we have. Now Azure has completely removing the Synapse. They are replacing with the Databricks. They are completely migrating everything to the Databricks. So they got to know that I cannot beat this Snowflake or Databricks. So it better. So I'll stop this Synapse. I'll go with my Databricks only. So BigQuery is trying a lot. Redshift is trying from lot of days, but these guys are not able to beat this Snowflake because Snowflake design architecture is like that. So Snowflake is providing a number of features. So these guys, he don't even how to clone those things. That much complex they have written. So that is the reason this Snowflake and Databricks are ruling the data warehouse present market. Okay, so but both are completely different. Snowflake has its own architecture; it follow multi-cluster like that. When it comes to Databricks, right? So Databricks cloned the Hadoop architecture as well as the Snowflake architecture. So when compared to Snowflake, Databricks is 1% further, but both have their own benefits. So if you are going to store trillions of record, so I'll tell to client that Snowflake is the preferable one when compared to Databricks also. Getting it right. Whenever there is unstructured data, then only we need to go with the Databricks. If there is structured and semi-structured data, Snowflake will be the preferable one.
Got it.
I worked on BigQuery and Snowflake. Okay, so BigQuery is like shit only. So we cannot do a wonders on BigQuery. Like the pricing also too costly when compared to Snowflake. Here the storage cost is cheap, but if I want to process a query, right, I cannot choose the warehouse. But in the Snowflake, I can choose the warehouse. If you see the Snowflake, For processing any query, I can choose my warehouse. So this is my warehouse. But in the BigQuery, so based on the query and data size, it will create one plan. It will choose his own warehouse, which is not good for business. Same option will be available in the Databricks. So you can choose the role, warehouse, and this all blah blah blah. Because Databricks has cloned Snowflake as well as Hadoop. It's a mix of Snowflake and Hadoop features. So that is the reason Databricks came now into high demand into the market. Okay. Done. If you learn one thing, you can play with other databases. It's not matter. If you understand the Snowflake properly, you can play with the other databases. So
Got it.
yeah. Okay, coming back. So where we are storing the data? We are storing the data in the table. And how I am storing the data? In the form of rows and columns. Okay. So if you are very new to the market, so what is row? It's a sleeping line. What is the column? It's a standing line. So it's a plain row and this is a pillars. You can imagine about rows and columns. Okay. Now, so row will have particular item information. Column will have specific value information. See, so I have stored student details. Now, if I want the details of Pawan, I need to check in the row. Now, if I want to know the phone numbers or email IDs related to the students, I need to check in the columns. So row will hold the specific item information. Column will hold the specific value information. Clear? Okay, if you are familiar with Excel, okay, assume Excel is a database, assume that tabs are like tables, and how we are storing the data in the form of rows and columns, right? On top of this, there is a header where we have the column information. Similarly, in the table, we have a metadata. We call that header as a metadata. And similar, how we are storing the data in Excel. In similar, we are storing the data in the form of rows and columns. Clear? To create a tables, we need four important things. One is four important rules. One is column name, data type, length, and constraint. Here, column name and data type are mandatory. Length and constraints are optional. Okay. Tomorrow we'll discuss about data types, and tomorrow we'll work on how to create the table and all those things. If you are familiar with this DDL, DML, DQL, I'll skip few points and I'll directly jump into the other points. It's better, like we have a lot of things to discuss, right? So just go with the YouTube videos for understanding this DDL, DML, and DQL so that I can go somewhat fast about this NoSQL. It's up to you. Okay. If you want, I can go slow. If we want to learn more, right? So we can skip this NoSQL. If you learn this SQL from the YouTube, it will be more helpful. So that I'll give some introduction about each topic and I'll jump to the next point. Okay. So I think you all know about this DDL, DML, DQL. So anyone is completely new, let me know. I'll go a little bit slow.
We can still discuss it, but we can go faster and discuss it.
Yes. Okay. Because yeah, it's very simple, right? DDL, DML, DQL, you already learned, I think so. So
Yeah.
I'll go somewhat fast, but I'll completely give complete idea and then I'll jump
Yeah.
into the next topic.
Yeah, like maybe we can have a brief overview of it and
Yes,
just
brief
move on.
overview and I'll write some queries and then we'll jump into the next one.
Yeah.
Okay.
Yeah. Thanks, all.
I
Thank
also
you.
have one more question.
Yeah, please.
You're recording all of these lectures. Are you posting them
Yeah.
in the document that you shared, or you're not posting the recordings?
Just go with this 2026 and then this is PPTs. In the left side, you have an option called notes. Let it load. Yeah, here we have an option called notes. In the notes, you have a SnowSQL. So in the SnowSQL, you will find all these DDL, DML, DQL, everything here.
Okay. Okay, thank you.
Yeah. Thanks, sir. We'll connect tomorrow.
Yeah.
Thank you.
Thanks.